Hi there, my name is Cadell. I run a company called SparkGeo where we, for the last decade, have put maps on the internet. I want to tell you a story, one which is unfolding in front of us, one which we can choose to be part of. First of all, thanks so much to John and the GeoIgnite team for this opportunity. He's managed to pull off this incredible series of events through significant adversity. So hats off. Nice job, John. Thanks very much. My background was originally in remote sensing, but I mostly left that scene for the first decade of my career, amazing myself here. Well, imagery was always present in my activities, but it was always kind of a lumpy data source, awkward, time-consuming, somewhat unsatisfactory. We would spend hours trying to make it perfect for analysis or presentation. Subsequently, Google has solved that for us by teaching the world that stripes and other artifacts were acceptable in base maps. But largely through the early 2000s, remote sensing fell out of favor. It was the domain of governments and militaries who cared about situational awareness, broad land mapping or scientific activities. All those applications involved the capture of an image and then its subsequent study. That's a story we're all very familiar with and one which suited the needs of that time. Since then, we've added 1.7 billion people to our planet and 0.5 degree Celsius. With those pressures come landscape changes, sometimes primary and sometimes secondary effects. In fact, chains of events are becoming the story of our changing climate. But I get ahead of myself. First, I want to talk about scale. Such an interesting word in our community. It now carries at least 3 meanings for me, and they're all relevant to this discussion. One, geographic scale is description, a ratio between physical world, model versions of our world, obviously a map. I am sure this audience is all too familiar with this definition. Scale can also reference web architectures. We might say that a particular web application is scalable or not. This could be to do with the magnitude of data, movement of web traffic. It might be the use of the cloud. It might be other implied movement of information through constrained information technology systems. Sometimes the use of the cloud might imply scalability. This is not always true, but better levers for scalability do exist within cloud architectures. In this case, the scale ratio is probably between activities and performance, i.e. a more scalable architecture can do more faster. To be quite honest, the definition of scalability of cloud applications is complex, deeply opinion-driven, and believe me, people who like to talk about scalable web architectures have opinions. Interestingly, if we're talking about geospatial applications, then geographic scale will have a significant impact on the scalability of a particular web architecture because geographic scale will impact the amount of data being moved. Businesses also have a notion of scale or an ability to scale. Scale is both a verb and a noun in this case. For instance, selling ads in your social network is extremely scalable. Running a service business like SparkGeo is less so. Scale in this case is usually a subjective ratio between revenue potential and resources. More revenue per resource implies a more scalable business. You can see that the word scale is used to compare two entities. One is physical, distance, activities, resources. One is maybe referential, model, distance, activities, or user experience, even revenue. With this in mind, what should we do with the notion of planetary scale? What does that even mean? Clearly, our planet has become increasingly connected and at the same time fragmented, I would argue, in the last decade. We do know that activities occurring in one location can have a deep and lasting effect in another, and even every other place. Meanwhile, we also know our society's dependence on globalization and the arbitrage of labor and resources at its foundation. It's a lot more fragile than we understood it to be. It took a pandemic and a blocked canal to bring our global supply chain, which had been built for the last 100 years or more, to a grinding halt. Clearly, all these concerns are planetary. They're all geographic and they all come with a variety of scales involved. Indeed, if we apply our definition of scale to the evergreen blockage, it was an enormously scalable error. On one side of the ratio, navigational slip, avoidable bump in the ship's wheel, if you like. On the other, well, the Egyptian government alone impounded the vessel and settled on a cool $550 million just for lost tolls and inconvenience. Every day that Suez was blocked, $10 billion of goods did not move. Frankly, the subsequent impact has not yet adequately been calculated. That was a scalable event. This presentation is going to examine two central themes in parallel. I want you to think about them both as they reference each other. One, how our abilities to look at planetary scale concerns have evolved. And two, how the challenges to our society, which we are increasingly facing, demand that we operate at this scale. How the challenges our society is increasingly facing demand that we must operate at this scale. In the year 2000, when I graduated, a benchmark computer was the Gateway Performance 1500, 1.5 gigahertz Pentium 4, and it optionally came with a gig of RAM. In 2010, when I started SparkGeo, Intel was pushing their i5 chips, and I picked up a machine with 1.5 terabytes pretty easily. Google also launched Buzz, if you remember. Why do we care? Well, computing capability is an asset that digital geographers like us have always valued, but we're not in direct control over. In business or strategy speak, we could call computing capacity a complementary asset. Complementary assets are worth watching because they often present new capabilities. More so, they can provide the foundation of disruption. The ice hunters of Northeastern America had built an excellent business shipping ice to the tropics, but were completely disrupted by residential refrigeration. Internet cafes were great until we had the internet in our pockets, supported by the complementary assets of mobile connectivity, smartphone technology. So let's think about digital geography. What do we have here? We have 5 complementary assets to which we should pay attention. Complementary, not free, but supportive. They complement what we do. 1, commercial space. We have gazillions of sensors. 2, smart devices. 7 billion GPS-enabled devices on our planet. 3, algorithms. We live in an algorithm culture. 4, we have the infrastructural capabilities of the cloud. 5, we have open standards. So let's think about commercial space. SpaceX has changed access to space, in particular low Earth orbit, by reducing the cost of access to our atmospheric real estate. It's become easier to launch sensors. In the past, small constellations of large satellites, each costing around $500 million to build and launch into space, were the standard practice. Now, constellations of small, micro, and nanosats are being launched seemingly weekly for many orders of magnitude less. In addition, SpaceX and their ilk, in addition to SpaceX and their ilk, the open CubeSat standard has allowed satellites to be stacked similarly to containers for shipping, albeit much smaller. This has created an environment where numerous sensors can be packed into rockets efficiently. Most of the cost of launching and building satellites have decreased enormously. Why should this matter to us? Well, traditionally, this imagery would be exceedingly expensive and would often be the domain of military intelligence communities. Now, imagery is fast becoming commoditized, largely because of access to low Earth orbit. Interestingly, more novel sensors are being launched. Radio frequency detection can launch, listen for radio traffic. Active sensors create radar images on our landscapes for detection of buildings, steep slope subsidence. We might even have swarms of active sensors rolling over our cities, giving us consistent updates. Methane sensors are now patrolling our skies looking for major polluters. The opportunity afforded by new space has injected adrenaline into the hearts of the geospatial community. These new sources of data are the reservoirs from which streams of geospatial analytics can be tapped. Smart devices. Today, 80% of the world's population has a device smart enough to provide a geographic position by GPS. The most advanced smartphones now also carry LiDAR 10 years ago, only the most advanced recreationalists would have had access to handheld GPS, and handheld LiDAR was an absolutely professional domain. From a sensory perspective, individuals can locate themselves on our planet with an unprecedented precision and accuracy. Now that location is not the domain of experts, navigation has become a default activity of smart devices. So one need never be lost again. These handheld devices are networked where available. Thus, if the device's user agrees, location data from half the world's population can be captured and put to work. This activity is famously been put to work with applications like Waze. If a user has a LiDAR-enabled device, then the three-dimensional model can be captured, describing their immediate surroundings. It took 10 years for GPS to become ubiquitous on smart devices. LiDAR will likely take much less time. This 3D capability will fuel augmented reality applications and help individuals enter their metaverses. Smart devices, therefore, offer the capability of both geospatial data capture and consumption, turning an individual into a node in their digital mirror world. Algorithms are interesting. A frequent discussion in the geospatial community is, so what? If we're being delivered with more imagery, what can we do with a tsunami of pixels when we have only so many eyes to look at the images? Algorithms plumbed into a cloud pipeline and then automated can turn data into insight. Whether these algorithms are monitoring plant health or slope stability or counting cars or measuring some other element of our physical surroundings, the rise of a culture of algorithms has supported the increased use of high throughput data streams, like those from low Earth orbit. This evolution has been accelerated in part by the computer vision and artificial intelligence communities, bolstering what was already a very healthy spectral and active sensor research community. Algorithms are our data refining capacity, distilling the raw pixels into products of value. Pixels absent of interpretation by humans and or algorithms are virtually meaningless, just numbers and mathematical arrays. The cloud. This amount of data capture also has tremendous implications for connectivity and data storage providers. However, in many ways, the cloud has provided a canvas on which to paint the context of the imagination of the technology sector. The notion of conceptually infinite compute implies that within a physical reality, a technology company can achieve what would have been impossible only a few years ago. The steady state of cloud advancement continually pushes back the edge of the computing possible. In addition to the infinite compute capability, the ease of network access should not be ignored. Pre-cloud architectures were limited by potential entry points. Now we can connect to a cloud architecture via a cellular network with ease. The cloud can be thought of as the infrastructure necessary to direct the flow of traffic and data across the web in a controlled and scalable manner. The result is that companies of any size can engineer solutions with conceptually infinite compute and massive accessibility without huge capital investment. Finally, open standards support interoperability and encourage full competition. Whether these standards are being used in software or in data management, commonly understood data formats and processing practices can help with the adoption of new technologies. The Open Geospatial Consortium, OGC, has been influential in advocating for open standards since 1994. Recently, these standards have evolved to support higher throughput data sources like those flowing from constellations in low Earth orbit. For instance, Spatial Temporal Asset Catalog, SparkGeo, we're a big fan. This will result in a common way for machines and people to search for imagery. Such a simple open standard allows organizations to easily search for data from different sensors using a common toolkit. In no uncertain terms, the change in technology capabilities has altered the geospatial landscape. And these 5 complementary assets I just outlined provide such a plethora of new opportunities that the enterprise geospatial community simply cannot keep up, leaving a deeply unsettled market. Consider how these assets intermingle. The rise of commercial space has provided an armada of Earth observation satellites. The cloud provides the infrastructure to direct the flow of data. The algorithms and open standards allow that data to be put to repeatable use, and smart devices allow users to interact with that data in a location-centric manner. Each one of these assets was a separate concern in 2000, and even in 2010. Few of these subjects really overlapped. Now, they all firmly overlap. I call this modern geospatial. You can call it whatever you want. There's some disagreement. The point is, these assets did not overlap 10 years ago. Some of these assets did not even exist then. These are new and evolving practices, and together they are bundling, provides a series of new capabilities which allow us to meaningfully approach planetary scale challenges, frankly, just in time. Let's quickly explore what combinations of those assets might mean for our community. We can access massive data flow that describes the changing face of our planet. Conceivably, that data flow might come from different providers, but if we have common open standards, those different providers can provide a common data product. We have algorithms to discern what those changes on our planet might actually refer to, and what we can interpret them as business people, as government people, as citizens, as whomever. And we have the infrastructure to be able to pipe that massive data flow around. It becomes credible, it becomes useful, it becomes real. And then we have the open standards, which means we can cross-pollinate those massive data sets with each other, or better yet, their derivative products. This multiplies our potential opportunities further. Closed standards are anti-innovative, open standards, open minds. With this model, we have the ability to let algorithms do more of the work. I've spoken to at least 2 satellite companies now who have an algorithm as one of their product personas. Being delivered an image every day is an enormous opportunity. But that is the product of nightmares for a GIS analyst, certainly in the private sector. Instead, think about insurance models. The algorithms are looking after your welfare and will kick in if necessary, if something has changed. The analyst doesn't need to look at anything unless it's absolutely necessary. But this further implies several business model necessities. 1, recent imagery is always available. 2, pixels from across a constellation are normalized. 3, that algorithms can access that imagery in a structured way. 4, pixels for algorithms are priced reasonably and probably differently from those designed for eyes. 5, locations are subscribed to rather than images bought. This last point is deeply nuanced but critical. When we consider the product of Earth observation, it is not wavelengths or arbitrary collections of colorful squares. The product of Earth observation used to be awareness, situational awareness. It is now change, dynamic, high frequency change. And this is why we are better positioned to tackle planetary scale activities than we have ever been. It's just in time though. In the last 9 months in British Columbia alone, we have had heat domes, wildfires, atmospheric rivers, polar vortexes, massive landslides, catastrophic flooding. And critically, some of these events are linked. A study completed by Alex Barrington and Brian Menounos of UMBC suggested that, given the accelerated rate of melting, glaciers could possibly disappear from the Rockies within 70 years. And meanwhile, in Saudi Arabia, extreme heat is a problem that will likely deplete further their scarce water reserves. Water, its presence and absence, will continue to cause global strife. And this is absolutely a global problem, a planetary problem.
Hi, Will.
Hi there, John. How you doing?
I'm great, thanks. That was another amazing talk, very thought-provoking, always engaging. Is this stuff come just through your daily work, working on these issues? Is that where this comes from? Where's the inspiration?
It comes from, I mean, like we pay a lot of attention and we work in a lot of different market verticals. So we're lucky enough to be able to talk to numerous different organizations and sort of start joining the dots between those organizations. And we try to collide those ideas within our team to come up with what we think are going to be the trends by looking at kind of weak signals and such. So yeah, we commonly have discussions of that nature in our team.
Must be a great place to work.
It's pretty good. I mean, we're all in our basements or our offices.
That's a nice
right across
basement.
Canada.
That's a nice basement.
Yeah, did you like it? It's not quite sunny. It's when we did the video, but it's it's all right. Yeah.
So something struck me during your talk that I wanted to ask you about, see if you could get into a little bit more. You mentioned that cloud computing, and I think that the open standards is leveling the playing field for small tech companies, and I would imagine the startups. I think about, when I heard that, I thought about kind of my own work with it being so much on the internet that a small company can look like a big company. It has the resources to fight way above its weight class, you might say, and present that. And it looks to me from what you said with cloud computing and open standards, we're there for small tech.
Absolutely. And I think what's really exciting is that you have this ability to test things out in a relatively inexpensive way. And then if it is real, okay, well, then we can apply scale and we can apply a business model, and then it can grow. And so the barriers to entry have reduced, and the same is true for the actual Earth observation companies too. The traditional barrier to entry was like a $500 million ticket to get a really large piece of infrastructure in the sky. I mean that's a significant barrier. But now it's reduced enormously. So I think Satologic was saying in a video I saw recently that they can get something in the sky for $1 million. And I think, well, that's a lot less. I mean, it's still a lot of money to you and I, John, but still, like conceivably, it's a lot less. So the barrier to entry, even there, for those Earth observation companies, is reduced. And then, so it's kind of a virtuous cycle because you end up with even more data being captured of the Earth's surface. And it's really up to software companies like SparkGeo or other sort of vertically oriented companies who know a lot about a particular domain to be able to go, oh, I'm going to apply my clever algorithm to this enormous amount of sort of pixelage coming out of the sky. And I think that's a really interesting opportunity for us all to be thinking about.
That brings me to my next point, something that you said. You were talking about distilling pixels. Yeah. And that made me think, well, that's like remote sensing alchemy.
Yeah. Well, it's really interesting because so I went on this trade mission to the UK. I like trade missions. Who knew they were a thing still? But anyway, this was immediately before COVID. So like literally weeks before everyone got locked down. So trade missions to the UK, and they all used this nomenclature for geospatial, which was you have upstream stuff, which was the satellites or whatever, and then you'd have downstream, which were the consumers. And then if you start sort of thinking about that, I think, oh, actually, that makes a little bit of sense because the consumers don't really want pixels. Typically, they want to know something about their business or something about their landscape or something about the ground. Like the pixel is just like an arbitrary kind of carrier of information that they turn into something else. So if we were to think of algorithms as like distilling capability, then it starts to make sense because you're turning it from something into something that's actually useful. And so the analogy or the cliche kind of holds all the way through. So I've often started, well, not often, I've been starting to describe SparkGeo as like, oh, we're like a Baker Hughes of geospatial. We build infrastructure that turns geospatial kind of refining or reservoirs into something productive at the end. It's kind of interesting.
Absolutely. So everybody, we got time for Q&A with Will. I took advantage there and didn't mention, put your questions in the Q&A. We've got one that's come in. Will, can you please tell us more about geospatial trends around ESG and maybe describe what's ESG for those who don't know?
Yeah, so ESG, environmental sustainable governance, it's kind of a bit ephemeral right now, but it's a series of standards that large organizations are going to be held to around their use of resources, their management of assets, and their management of people. Frankly, that's the social piece, and how they govern their organizations. And it's felt, or we feel strongly, that geospatial should be playing a part in that realm. You see it in this kind of notional, and I think you referenced it when you're talking to John. This notion of spatial finance is really important. But what does that really mean? Like, what do finance people really want to know about our changing planet? Well, traditionally, where landscapes change and where humans move, that's really where value has been determined broadly. So it's actually critical. That's actually where commerce occurs. So if we can measure that in some meaningful way and provide feedback, then it becomes much more real. It becomes much more useful. And I think that's where our community, the geospatial community, needs to kind of understand the products of the future, the products of these other organizations, so we can provide meaningful analytic descriptions of our ground, which probably aren't maps and they probably aren't pictures and probably something else, but we're not quite sure what that something else is. And it'll probably change depending on what commodity, landscape, activity, or asset that we're trying to measure in some way. So I think that's a really interesting sort of piece of the puzzle. And it's a very unsettled market. We don't really know what it's going to look like. We're waiting for regulations to drop to see how that's going to affect us. But certainly we see that as an enormous market for organizations like mine, but also for the Earth observation community as a whole.
Absolutely, thanks. Taking us in a little bit of a different direction, you've mentioned the metaverse. I was wondering, are you working on any projects with clients that you can talk about that are helping them related to the metaverse at all? And could you maybe start by giving us what's your definition of the metaverse?
What's my definition of the metaverse? I think so. Yeah, we are. I can't talk about specifics. I can talk about generalities.
Absolutely. Yeah.
The place where we engage in the metaverse is by helping organizations and companies describe our actual planet in a meaningful way. So we engage with a couple of metaverse companies who are building experiences not dissimilar to Monopoly, if you like. It's a game. People are sort of buying and selling real estate in that game and they're trying to sort of accrue value in some manner. So we provide information around sort of planetary resources. So like where's the forestry, where's the rock, where's the water, that kind of stuff. Turns out we're really good at creating those data products. So that's where we've been engaging in that market. But I think the metaverse will become a much bigger opportunity for geospatial companies. And the neat thing is, like whether it's a representative geography, like our actual geography, or whether it's a fictional geography, it doesn't really matter. It's still a geography, and we have all those skills. So why wouldn't we be applying them to a gaming environment? Why wouldn't we be applying them to a metaverse environment? What's going to be really interesting in the metaverse space is when metaverses start like really sort of joining together. There's no kind of magic doors between each of these experiences yet, and I think that's when you get to the kind of the Ready Player One thing, which we're not quite there at that point. But so now, right now we have all this. We have this stack of metaverses that you can engage in independently, and I think when you can engage in them together, I think it'll become a more real thing, if you like.
Thanks. So it's always super engaging to talk to you. We've gone into our break because it's so engaging. I wanted to give you an opportunity to talk a little bit about the workshop that SparkGeo has put on. Can you tell us a little bit about it and who should go to that?
Yeah, so we're doing a little bit around it actually in reference to something that our video was talking about, landslides in British Columbia, and joining together kind of like the scientific process all the way through to kind of a cloud process. So that's going to be pretty interesting. We're kind of loosely linking increased water flow from I'd like to steal their thunder here. Increased water flow, based on rain events, but particularly around places where wildfires have occurred. So there's less vegetation on steep slopes becomes a major problem. But how can we measure it? How can we turn that into kind of a cloud workflow and such?
Fantastic. Will, thank you so much for sharing your time and expertise and insights with us. And thank you for SparkGeo being our gold sponsor this year.
Thanks very much, John. It's been wonderful. As always, you've done a great job with GeoIgnite. Much appreciated.
Thank you. Okay, everybody. That's it for our second day keynote. We've got coming up after a very short break, we've got Deploy Solutions. Nick Kellett is going to be talking about building software solutions for climate change. We're looking forward to seeing that. I will see everyone on the other side.